Hello, everybody. So I hope you're all doing well. And in this video, we have a question from the IB Chemistry HL Paper 1 from the November 2020 batch. So this question asks, which of the following acids has the weakest conjugate base? Now, we've been given four options. And out of these four options, we can actually eliminate one, well, easily. We can eliminate C because C isn't even an acid. C is a salt. And this is the salt of a weak base reacting with a strong acid. So it's NH3 plus HCl gives NH4Cl. So that's just some general information for you. So this isn't an acid. This is actually a salt. So that's out of the question. Now, out of the other three options, right, they all look quite convincing. Right? Any of them could be it. But actually, if you do know your acids and bases well, you will know that the conjugate base is the strongest for an acid which is the weakest. So what I mean to say is, the weaker the acid, I'm just going to put a down sign over here to make to show that it's weak. The weaker the acid, the stronger its conjugate base. And vice versa. So by vice versa, what I mean is the stronger the acid, the weaker the conjugate base. Now, some of you may be a bit confused. You'll be like, okay, what is a conjugate base? Now, if you don't know what a conjugate base is, that means that you haven't studied this topic, because that's actually one of the first things that comes up in this. But for the sake of this video, I'm going to explain what a conjugate base is, but I will highly recommend you to go and read from your textbook or other resources about what a conjugate base and a conjugate acid and the Bronsted-Lowry or the Lewis theory is. So please do that. But for the sake of this video, I'm going to explain what a conjugate base is. So I'm just going to take a reaction. Okay, let's say we have NH3 plus H2O. Okay. So this sign means that the reaction is reversible. Oh, sorry, my apologies. I have done that wrong. It's actually 4 plus. Now, in this equation, we can actually define what a conjugate base and a conjugate acid is. But now, for you to understand that first, I'm going to throw out some definitions there. So in this reaction, I will be talking about three things, or at least four things. So there'll be the Bronsted-Lowry acid, and then there'll be the Bronsted-Lowry base. And then I'm going to tell you what a conjugate base is, plus a conjugate acid. So I'm going to discuss these three terms. So the first one, what is a Bronsted-Lowry acid? So basically, a Bronsted-Lowry acid is anything, any substance which donates a hydrogen. So in this case, in the case of this reaction, just this reaction over here, the Bronsted-Lowry acid is H2O because it has donated one of its hydrogens to NH3, and thus NH3 becomes NH4. So a Bronsted-Lowry acid in this case is H2O. What is a Bronsted-Lowry base? A Bronsted-Lowry base is any substance which receives or it consumes AH plus. And in this reaction's case, the Bronsted-Lowry base is NH3 because it accepts the hydrogen given by water. But then if you look at this reaction over here, because remember, this is a reversible reaction, so you can actually look at this reaction both ways. In this reaction, the positions swap. The OH minus becomes the Bronsted-Lowry base because it takes one hydrogen from NH4 to become water. And NH4, when it donates one of its hydrogens, it becomes NH3. So that's why the positions have been swapped. And in this case, OH minus becomes the Bronsted-Lowry base and NH4 becomes the Bronsted-Lowry acid. So BLA is Bronsted-Lowry acid and BLB is Bronsted-Lowry base. Now, what is a conjugate base and a conjugate acid? So conjugate base or a conjugate acid is this. This OH2O and OH minus are a conjugate acid base pair, meaning they're interchangeable. Basically, what this means is that one of them acts as a base and the other one acts as an acid. So in this case, OH minus acts as a base and H2O acts as an acid. So that's what a conjugate acid base pair are. Now, in this case, they've asked us which of these acids has the weakest conjugate base. So which of these acids, when it donates its hydrogen to form a conjugate base, which acid produces the strongest base? And we know that the stronger the acid, the weaker the conjugate base. And in this case, we can eliminate B, D, and B because these both are not strong acids, they're weak acids. And HCl is the strongest acid. Thus, it is the right answer because since it's a strong acid, it will produce the weakest conjugate base. And this is the right answer. So I hope that that video has kind of explained to you what a Bronsted-Lowry acid is and a Bronsted-Lowry base and what a conjugate acid base pair is, and maybe cleared some of your doubts on this topic. Now, just before we leave, I must also mention another thing. NH3 and NH4 are also conjugate acid base pairs because one has acted like a base and the other acts as an acid. I just wanted to put that out there to avoid any confusion. So that's it for this video. I hope it has helped you. And if you have any questions on this topic or any other topic, please message me on my social media, send me an email or put it down in the comments below, and I will be more than happy to help you. Thank you so much for watching. I'll see you in another video with a new question.